this video we'll be looking at solving absolute value inequalities. So our essential question will be, how do I solve absolute value inequalities? So this is very similar to our absolute value equations. We'll have some special circumstances, and then we'll discuss how to solve them. So first, our very first step is, as like we did with the absolute value equations, we must isolate the absolute value. That's the first thing we have to do. We can't look at any of these other cases until we've isolated the absolute value. So we'll do that first. 2, we'll talk about our two situations where we can get all real numbers or no solutions. So A, if the absolute value is greater than or equal to a negative, if the absolute value is greater than or equal to a negative, we get all real numbers. And B, if the absolute value is less than or equal to a negative, no solution. So once we've isolated our absolute value, if we see a negative on the other side of the equal sign from our absolute value, we know our answers are going to be all real numbers or no solution. Okay, so what if we isolate the absolute value and we end up with a positive? Well, we have two different situations. A, if we're greater than or equal to a positive. Step 1, create two inequalities. We'll create two separate inequalities, just like we did when we had absolute value equations and we split it into the two equations. Now we'll split it into two inequalities. One with positive value using greater than or the greater than or equal sign, depending on what we start with. If we start with greater than, we'll keep using our greater than. And one with negative value using less than or equal to. So we switched that absolute value sign when we were looking at the negative side of things. And the last part 2, or from our compound inequalities, or goes between two inequalities. Then we'll have our B side of this, and that's when we're less than or less than equal to a positive. So step one is the same. Create two inequalities. One with positive value using less than or equal to, one with negative value using greater than or equal to. In step two, and goes between two inequalities. So there's a lot of moving parts, a lot of situations to be mindful of, but it'll make more sense, I think, once we use some look at some examples. Okay, so let's dive in, and we'll do some straightforward examples to begin with, number 1 and number 2. And we're just going to follow this either 3A or 3B for number 1. So we have an absolute value of x is greater than or equal to 4. Is our absolute value isolated? It is. We don't have anything on the outside of it. For example, like number 5 or number 6, there's no numbers on the outside of the absolute value to deal with, so our absolute value is isolated. Now, are we in A, where we start with the greater than or equal to, or are we in part B, where we start with a less than or equal to? We're in A, because we have a greater than or equal to. So we'll create two inequalities. We'll drop the absolute value, and we'll have x, one with the positive value using greater than or equal to. So we have x is greater than or equal to, so I'll keep that symbol, and I'll use the positive value. My second inequality will be the x, dropping that absolute value, and then I flip the sign, and I use the negative. Like that. And what word goes in between the two inequalities? Since we started with a greater than, we put or. And that's it. So the idea is once we've isolated the absolute value, whatever's in the inside of the absolute value, we're going to have greater than that value, greater than 4, and whatever's on the inside of that absolute value will be less than the negative of that value. So negative 4x is less than or equal to negative 4. And since we started with the greater than, we'll put the word or in between. Then we'll graph our solution. 0, 4, negative 4. I have lines underneath, so I'll put closed dots at 4 and negative 4, and I want to represent everything that's greater than 4, so we'll shade to the right, and then everything that's less than negative 4, so we'll shade to the left. Looks something like that. Okay, let's look at number 2. Our first part, is our absolute value isolated? It is. There are no items, no numbers on the outside of the absolute value. We got some stuff on the inside that's a little complicated, but there's nothing on the outside. So our absolute value itself is isolated. Okay, so are we looking at 3A or 3B? Well, we began with the less than, so we'll look at 3B. So what we'll do is we'll set up create two inequalities. All the stuff on the inside, and we'll one with the positive value, so using positive 45, and we'll use our symbol that we started with. So we started with the less than, so we'll use the less than. And then our other equation inequality will be 5x plus 20. Then we flip the sign and we look at the opposite, so negative 45. And then what word goes in between? And. Now we're just solving the two different equations separately. So I have subtract 20 from both sides. We have 5x is less than 25. Divide by 5. And x is less than 5. And then we have 5x plus 20 is greater than negative 25. So we're solving for this one. We'll subtract 20 from both sides. And then we'll have 5x is greater than negative 65. We'll divide by 5, and we get x is greater than negative 13. And then we'll bring our and word down for our final solution. So we have x is less than 5 and x is greater than negative 13. Let's graph it right over here. And I'll put negative 13 and 5. We have no lines underneath, so we'll use open circles. And we want to represent where x is greater than negative 13 and where x is less than 5. So if it's an and statement, remember we don't have the tails that go on forever on both sides. We just shade in the middle of the 2 points. So this goes with number 2. Like that. Okay, number 3. We'll just do 2 more. I'll do 2 more with you, and then I'll have you do 5 and 6 on your own. So number 3, when we're looking at this, this one's really straightforward because I have less than or equal to a negative value. So as soon as our absolute value is isolated, we have no numbers on the outside, and we see a negative value on the other side of our inequality, we can go straight. We kind of are. No, we don't have to do any math. We can look at our solution. So if the absolute value is greater than or greater than equal to a negative, all real numbers. While number 3, we are less than a negative, so we're not part A, but let's look at 2B. If the absolute value is less than or equal to a negative, no solution. So we are less than or equal to to a negative, so no solution. Okay, let's look at number 4. Okay, so here's a case where we actually have to isolate the absolute value before we can even start thinking about this. I can't make a decision on if I'm using 2 or 3. I can't make that decision yet because first I have to isolate my absolute value. So let's isolate the absolute value. I'll add 3 to both sides. Now I have the absolute value of x is less than negative 1 plus 3 is 2. Now I can make my decision. My absolute value is isolated, and I have a positive number, so I know I'm looking at part 3. And we're looking at less than a positive, so we're going to do 3b right here. So let's split it up into our 2 inequalities. X is less than 2, and we're going to use an and word when we start with less than. X is greater than negative 2. We'll graph it. We'll have 0, 2, negative 2. We have no lines underneath, so we'll use open circles. And we want to be less than 2, so to the left of 2, and greater than negative 2, so to the right. So since it's an and statement, we will shade in the middle. Okay, so there's some examples, 1 through 4, on how to do this. If you want, please go ahead and try on your own 5 and 6. Pause right here, and then we'll look at them quickly together. Okay, so hopefully you took the time to try 5 and 6 on your own. I'll try to run through these pretty quick. So first thing, I need to isolate my absolute value. So I'll subtract 3 from both sides, and we'll have the absolute value of x plus 2 is greater than 2. Now we can drop our absolute value sign. We are greater than a positive, so I'll have x plus 2 is greater than 2. Since it started off with a greater than, we're going to use the word or. So we'll go or x plus 2 is less than, flipping my inequality and using the negative value of 2. So we kept the absolute value the same, or the inequality the same, and use our positive, then we flipped it to use our negative. Now we solve, subtract 2 from both sides, and we have x is greater than 0, or subtract 2 from both sides, x is less than negative 4. Graph our solution, 0, negative 4. Open dots on both of them, and we want it to be greater than 0, so we'll shade to the right of 0, and less than negative 4, so we'll shade to the left of negative 4. There's number 5. Number 6, always that first step, do I have values on the outside of my absolute value? If so, we must get rid of those numbers before we can even think about what the absolute value is doing. So let's isolate that absolute value by adding 5 to both sides. And we have the absolute value of x plus 4 is greater than negative 3. Well, anytime I have an absolute value is greater than a negative, we know something's happening. We have a special case when we have a negative once we've isolated our absolute value. And then we'll just go, well, if it's greater than a negative, my solution has to be we are greater than a negative, so all real numbers. And we're done with that one. Okay, so that's how we can solve absolute value inequalities. Thank you for watching this video, and have a great rest of your day.